these goals. The first pillar is swab testing in Public Health England labs and within the NHS in their hospitals.
Alright, so let's start. It's exactly 6, perfect. I hope the sound is okay. I don't have it here, so if you can't hear me clearly enough, just say it in the chat. So there's YouTube and Twitch set up for the first time. I have no idea how well this is working. Again, if you're on one of the two and you don't experience the sound well or anything, just let me know in the chat. The two should work. I think YouTube has a fair delay compared to Twitch. So yeah, if you can, just switch to Twitch, otherwise YouTube is fine. So the last time what we had was, let me get there, try to zoom this a bit. If we add a to-do list to this, if we add a to-do list to what we have to do today, first thing will be getting to JuMP 0.21. That's the biggest point, I think. The last time we did a PR which switched from JuMP 0.19 to 0.20 and removed all the warnings and so on. Now that we have this, once we have this, another thing I wanted to do is try to start indicator tutorial, constraint tutorial. So that will be, so there's an issue about this on the repo. So indicator constraints are a new feature in JuMP. Well, it's been there for a few months now on math of the interface, and there's now a specific syntax in JuMP for this. So it's mostly for integer programming, if you're familiar with it. And so it would be nice to have a tutorial for this. And the last thing, if we have time, is try to look at the Bender's tutorial, there's just one, and look to add a version with lazy constraints. Sorry. So lazy constraints was added recently in JuMP and math up interface. So you have now a generic way of specifying to your solver, I want this constraint to be lazy, meaning just use it in the solver or use it in the solution process only when the constraint is active. And so this allows having more constraints at the beginning up front, specifying them more all at the same time, but the underlying solving process, so your simplex or interior point method, doesn't use them all from the beginning. I think this is mostly used for simplex, for the simplex method. Alright. Yeah, I think that's mostly it for now. So yeah, let's start. The easiest thing will definitely be JuMP 0.21, because this is strictly the same process as we did last time. So yes, let's save that for now. I'll try not to commit to do to the repo. That will be anyway. I don't think this will be accepted. I'm gonna check that I have the latest version. No, I didn't have the latest version, so that's perfect. So there's been few changes. I think that was the last PR from last time that's been changed here. So not much. And yeah, let's get back to creating a new branch. So it will be JuMP 0.21. Nope. We still have that branch JuMP 0.20, which we should branch D. We should delete it. It's not useful anymore because this was merged already. And we'll do the same thing with warning data. Yeah, that was we just have now perfect master and JuMP 0.21 that we're working on. So get status. Okay, the only thing we added was to do for now. So let's try to keep this here for commit and so on, and this one for opening Julia windows and so on. Yes. one thing I did is instead of plain Julia REPL, I'm now using Oh My REPL. This is after watching Abel's stream. I was pretty jealous of it. It has nice colors, nice features, matching brackets. If you have a bracket that's not matching, it highlights it in red and so on. So that's nice. So yeah, it's very cool. It just slows a bit down the REPL, I think. So that's great, but at the same time, it's a bit of a pain on some few things, like starting the REPL and not having it immediately available. That's why I did this enter here, because it was not available directly. Okay. So the thing we wanted to do is add JuMP. So if we look at status now, it should be JuMP 020, and that's the case. Perfect. So what we'll do is switch to JuMP 021 at 021. Project compatibility. Yes, that's perfect, because we actually modified project toml to specify the compat here. So the fact that we cannot do it is perfect, because that's what the compat section of the project toml is doing, saying you can't have something that's not compatible with JuMP 0.20, and the only things that are compatible is any version that's not with 0.20. something. So what we'll do now is switch to JuMP 021, and the rest is not changing, and that will be it for now. So it means now we should be able to add JuMP 021, and it should just work. So now status, and nothing did change except this one here, and that's it. So now what we have to do is first we'll test everything. Is everything working or not? So it was working the last time, so it should obviously be working this time, except that we changed versions. So if something has been broken in the meantime, we'll see it now. I hope not. I hope what we'll see will be a warning at some point. And I think we will see a warning. Also, while the tests are running, so Abel recommended my stream when he was doing his. So if you're interested in quadratic programming, anything nonlinear, the whole smooth optimizer ecosystem, go check out his channel. So Abel Siqueira. Am I doing this right? Or am I butchering your name? Whew, okay, all good. I almost said it right. My Portuguese is way worse than your French. Empty intersection between JuMP 021 and project compatibility. Oh wait, that was before. That's because obviously I relaunched this here. Okay, so the first thing we see now is interesting. We have this warning here, which is nice because it's not breaking, but it's telling us that with optimizer, this syntax will be deprecated in the next releases. So it means it's now deprecated, and it will be removed afterwards. So what we'll do is check first. So we'll quit this, and we'll check when is with optimizer used. Yeah, quite a lot. We'll do it in scripts, because this is where it's interesting to see. Quite a lot. So with optimizer is basically specifying when you create a model, you pass it this with optimizer, which is creating or specifying how you want to create the optimizer. So it's now been deprecated. So when we have something like model with optimizer GLPK optimizer, we'll just replace this with just GLPK optimizer. So we just remove this with optimizer. When we have something like this, we'll need to add with optimizer arguments or something. and to know, oh, one test broke. That's interesting. Load error. So that's, I thought this would be a warning, but here it's an error. That's fairly interesting. Okay. Set optimizer before optimize. Okay, so this one will definitely need to be fixed first, and that was test introduction solvers and solution 20. So it means yeah, so that's in line 20 but on the test. So we'll try to include script, so introduction and solver and solutions. That was it, right? Yes, solver and solutions. So we'll include this and we should get the same error, and then from this error we can know which line we need to modify. Again, if you have not checked the previous stream, script is where the basic scripts are written, so that's our base files, and these generate some test files that we run in the test and some notebooks. So we should not modify the notebooks themselves, and we should not modify the test files because these are generated, so we should just run them or tune them a bit, but not that much. Okay, so cool, we get the same error and it's at line 63. So let's get there. Yes, exactly. Okay, so here this is what this is doing here is saying optimize this with this given optimizer, and an optimizer is just the JuMP specific vocabulary for a solver, for your the underlying solver of your optimization. So the recommended way is set optimizer before optimize. Perfect. So this will be set optimizer, and that's model auto no, and then optimize would just be that. Alright, let's see if it works now. So we have the same warnings as before, that's fine. The model was not solved correctly. Well, that's sad. And where is that? 169. Oops. Nope. 169. The model was not solved correctly. Okay, I think this might not be a real error, but this might be an error that's on purpose here in the notebook. So what we'll do is maybe, yeah, we see this tangle equals false means we can have an error, and that's fine in the test. Well, we can have an error, so don't consider this error as an error in the test. That's basically what this is saying. So to confirm this, what we'll do is import JuMP tutorials, and JuMP tutorials, nope, not that, with file, and this was yes, that one, solvers and solutions. These matching parentheses are really nice, so it makes me accept more of a slight delay at starting Julia. Nope, no such file. Is it not in using JuMP? Introduction. Warning, updating test for solver. Okay, yeah, seems legit. so this is again so from one file, which is introduction/solvers and solutions, which is in our script folder. This with file is generating the test and the notebook. So the easy part is the test, and the hard part is usually the notebook, which requires firing up a Jupyter notebook, producing all the cells, executing all of them, and so on. So this is a bit heavier. I hope this is not breaking, because if you watched the stream the last time, you saw we get huge stack traces that you don't get anything of, and so on. So as long as the errors are in Julia, you're good. Whenever the errors go into the land of Python or the Jupyter server, then well, it gets a bit more tricky to solve things. Alright, no error, wonderful. And now include, so it will be in test. Nope, we can't include. Oh, okay. So it would be in test, introduction, solvers, and solutions. Yes, include that, and this should not error. This should still have the deprecation warnings, but not any error this time. Okay, perfect. That looks great. So this is fine, and then we'll just rerun all the tests once. Okay, and in the meantime, I'm trying to think how are we gonna replace this. So if I was a regex wizard, I would just check that model is just calling with optimizer with this thing and nothing else, without any parameter, and then you can just replace it with model GLPK optimizer or model your optimizer. Sadly, I'm not a regex wizard, so this might have to be a bit brute force and overfitted to our problem. What I might do is just fire up a more standard editor and replace things. This looks reasonable. The other thing is, yes, I wanted to check the syntax on how to set an optimizer with given arguments. In the meantime, so I'm really not using Visual Studio Code that much, so I'm not sure how friendly this will be on. Yes. So what I do here is search in the whole things with optimizer, no regex, right? So this will be glpk dot optimizer. Yes. So when we just have that with optimizer, glpk optimizer, we can replace it. So this is Control H. I never remember. No. No. Selection. How do you Control H? Yes. Why is this not working? Control H. Okay. Well, it seems the shortcuts are, well, not working. Interesting. No big deal. Alright, we'll have tried all the possible editors. This one should be fine. So, finding projects. So this was with optimizer. You should have a ton of them here. glpk dot optimizer and nothing else. Optimizer. Yes, and replace this in project with just glpk optimizer. Replace all. Okay. Alright, I think we have done the hard part here. I hope there are not that many still. with optimizer syntax. Okay, we'll have to remove this. Oh, also I should not replace everywhere. I should have replaced only in the script. So, oh no, I'm in script. That's perfect. In the meantime, I also checked, did my test finish? Nope, not yet. Oh, okay, going fast, but not that fast. All right. So with optimizer. So the first thing here is a model object is a container for variables constrained. The models are created with the model function. Okay, that stays the same. Here, with optimizer syntax, it is used to specify the optimizer to be used, which is JPK in that case. So we'll replace that with how can we put it? The model can be created with an optimizer attached with default arguments by so how do you say this here? Open source is really at least as much English as it is code. Attached with default arguments by calling the constructor with the optimizer type as follows. Yep. Anyway, usually these kind of documentation comments is the things that your reviewers, your pull request reviewers are here for, like debating, is this ambiguous, is it too ambiguous, is this compact enough or too big. Alright, so this was a big thing, and then yes, for this part, so all the model with optimizer and some arguments, we will need yes, the only one we can replace is this one here, which was just like the GLPK ones, and all the rest they do require some arguments, some additional arguments, and for this we will need a specific syntax, and I think the syntax is specified in the warnings we get. Oh, our test failed. Interesting. JuMP tutorials test run test 28. No method matching add to expression adjoint. Add to expression. Interesting. So let's see where this is exactly happening. Test run test. Optimization concepts Koenig 28. So let's see if we get the same error by including the file directly. So that will be nope. Script optimization concepts Koenig programming. And I'm still struggling quite a bit with QWERTY keyboards, especially since switching between standard US and international US keyboard layout. So yeah, I do have lots of typos, mistakes, and missed keys and so on. Okay, so we get the same error. That's good news, kind of, and we can see where this is happening. 135. Here, dual model u times 1 plus what is that? So I guess this is the part that's failing. So what is u0 here? u0 might be, I guess, a vector of size y2 of the same size as y2 minus 1, so that these dot product here will work. One thing we can do is try to replace this with a dot product, which is from linear algebra instead of a transpose, and this is also more sound, I think, from a linear algebra point of view. I'm really in some lands that I don't master completely here, but I think you assume by transposing a vector, it doesn't make sense as a vector in a vector space. It makes sense as a row, as a column matrix. Somebody from Smooth Optimizer is gonna shout at me if I say something stupid, I guess. But yeah, like this, it makes more sense anyways, so we'll just keep it like that. Dot not defined, yes, absolutely, because I do need using linear algebra. Right. Okay. So this is the conic part of the scripts of the tutorials that I am not too familiar with as concepts. We'll see. CSDP not found. How come? How are we using DP? Oh, where is that? Using CSDP, and we have CSDP not found. That's very curious. I'm not even sure how this is possible. CSDP. No, it's not there. It's very curious. I don't know how it happened. One thing I might want to check is this a real package? As in, does it exist? CSDP. Yes, it does. Okay, it seems to be a valid package. Interface for corner semi-definite programming. Yes, that sounds about right. Oh. So I hope I do not need all these steps to get it working. I really hope not. Otherwise we'll just give it up for now. But what's fairly strange is that so what's fairly strange is that it did not error before when we did the last stream, so curious. Is it not even in the manifest? Nope, I'm still in scripts. CSDP. Nope, it's not there. Huh. I have no idea how this worked. So we'll add CSDP, which will... Yes, it's there. Oh, questions. How are you doing? Fun. Oh, thanks for a compliment. All right. So CSDP 05. We might want to keep a specific version for later. For now, we'll just include. Am I in scripts? No. So I'll try to rerun this again. I hope now this is working, but I had no idea how this was working before. But well. Okay, we still have some. Right. This is the syntax I was looking for. We still have the warnings, but now when we have a warning when with an argument, so here with optimizer IP opt with this parameter added to it, this becomes optimizer with attributes. Oh, and this has to become okay. This has to become an arrow. So this again, if I was a regex wizard, we could do it. But for now, I guess I'm just gonna have to go through them manually. I hope not. No, I might try to just get the biggest cases through Atom. First thing is I might want to wait for this to error or not to error. Alright. So, getting back on that. One other thing I should do once is learn to use sed and other tools like this. For the moment I haven't, so we're gonna have to stick to some very basic things like Atom with replacement. So yes, I wanted to launch Atom in script to get only the script to modify. We don't want to modify everything with optimizer. So I'm gonna try to fetch the very basic cases like this one. I guess for these I might just want to replace it with what was given in the warning, which is what was the warning again? Yes, that with optimizer with attribute and then the pairs. Alright, let's do that. So yeah, some fairly ugly manual work here, but well, sometimes what needs to be done. Alright, better. Okay, this is not specifying. This is not specifying here the way optimizer syntax, so we don't need to change that. Alright, so this we changed here. Same thing. Oops. This was okay. Here. Okay. Are we getting? I think this one is coming quite often, so we'll just and we'll replace this with. Did I already forget the syntax? Optimizer with attributes. Yes. IP optimizer, and then this becomes an arrow. Okay. Find all, replace all. Okay. Okay, that's better. Do we still have some with optimizer? Yes. This one seems to be coming quite often, so that's nice. We'll just replace it. Oh, we'll just replace the inner part, so this, and replace with optimizer. I'm really not gonna catch this name. with optimizer with attributes. Alright. Okay. And now if we look for with optimizer alone, do we find something? Yes. Yeah, these ones will replace them manually. So optimizer with attributes and optimizer with attributes. Okay. Alright. So now we just, I guess we have to regenerate everything. So import and JuMP tutorials with all. Yes, like that. It doesn't take any arguments apparently. Okay, no, these warnings are fine, so we're all good here. Oh, that's bad. I didn't notice. So kernel died. That's not great. Yeah, also one thing I will have to do that we got bitten by last time was fixing the running everything with Julia 1.0, because otherwise it will use some packages that are not compatible with it, and then Julia 1.0 will fail, and we don't want that. The JuMP organization made some fairly big efforts to get JuMP still working now on Julia 1.0, which is more or less the LTS version, the long-term stable version. So it means it's worth it to keep everything working with Julia 1.0 now, which means I will not use my default of Julia 1.4, but use Julia 0 -- project, and I will use this to test that everything is working. I think I will get some packaging compatibilities with this. So it seems the kernel died once for this one, apparently. So I hope this is just a one-time mistake, otherwise we'll try to rerun it with Julia 1.0 and hope again this will all be fine. Writing to file. No kernel dying, that's good news. We can keep up. And the tests seem to be working fine for Julia 1.0, so that's great news for now. This means just the fact that the tests are running and that the package could be resolved, it means the manifest now is fine, and no version has been added that will not be compatible with it. One thing we should do maybe once is no, yeah, this style here is not great. Like if you have two vectors that are really vectors, using vector transpose times vector might not be the best for comprehension, and we might better use dot products directly. So maybe this should be replaced in the rest of the notebook and not just the one we fixed. Oh, error. Log level not defined. Okay. Log. Oh, if I check again the warnings from before, log level not defined might be that. Yes, the key here has to be in a string. It's not a keyword argument anymore, so it means we have to replace the verbal names we used with strings like that. So yeah, that's not great. So we'll start with. Okay, is this still running things? Okay, and this is. Right, we'll quit here. So I'll be looking for the arrow, which is a pair constructor. We have a lot of them. Okay, we'll just start with the easy one. How can I find them all? With attributes. Question. Hi Matthew, I joined a couple minutes ago after you started and didn't attend the branch session. Can you briefly say what has been happening? Yeah, sure. If I understand correctly, there appears to be a compatibility issue with the JuMP tutorials package. Yes, more or less. So it had been sleeping for quite some time, the JuMP tutorial. And so what I'm trying to do here is upgrading from, so what we did last time was upgrading from JuMP 0.19 to JuMP 0.20. And there were some things breaking and some other things that were not that great that we could modify easily. So we basically did 3 pull requests, one very minor one, just seeing is everything working. If I don't do anything, is Travis and continuous integration still working? The second one was getting things to work with JuMP 0.20, and the last one was getting warnings to be removed with JuMP 0.20 and everything to work smoothly. So that was last time, and now we want to jump from 0.20 to 21 with some other compatibility issues to remove. And then once this is done, we want to maybe create a new tutorial. If you want to see the to-do list, to do here. That's the to-do list for today. So that's the thing we're doing now. So bumping everything to JuMP 21. Then indicator constraints, so creating a tutorial for it. And then that's the optimistic version. If we have time, will be modify the Bender's decomposition tutorial to add lazy constraints, but I don't think we'll have time for this today. Alright, so this is still generating our files. So again, to sum up what this thing is doing, if we go back up, this is weave all, so weaving all our files. So what we're doing here is taking all our scripts, which are formatted Julia code with specific comments, and from this is building Jupyter notebooks on one side that people can explore, play with, and so on. And this is also building tests, which is the same thing with all the comments removed, just to test that notebooks are not erroring or anything. And this is in the process of generating all these new files. in the meantime, what was here? Yes, we need to, all these optimizer with attributes, they have errors in them. So what I'll do is, on one side, I just look for everywhere where this is. Maybe unzoom a bit to keep things visible on screen. And on this side, I'll just go through them and replace. And maybe I can replace them not too manually. I hope. So what I want now is so I basically did a mistake with all the syntaxes. This is a good example. Here, you're supposed to provide a pair with. So it was initially a keyword argument to a function call. And now this is replaced by a normal argument, and this is a pair. This is creating a pair object with a key and a value, but this key here needs to be something that exists, and we basically need to put that in quote. So what I do is look for all the occurrences of this. Okay, cool, there are several of them, I'm not doing this for nothing. And replacing this with that. Okay. I'll check all the other places where we have something set to 0. I think there's also verbose. Yes, log global. And we want to replace that with the string version of it with log global like that. Okay. I think there was also verbose. Yes. We'll replace it with verbose. And did we have other things? Log level max iterators, okay. So it was max iterators. So this must be for IP up. No, CBC. So we can pass it a max iterators parameter. That's interesting. So I know this is really not that great to have everything done with Atom and manual control Fing everything. But yeah, again, I'm not a set wizard. I should definitely learn it. What else do we have? Print level. I thought we did this one. Oh, it's for another one. So print level will be replaced with stringified print level like this. Final. Place all. Okay. Alright, what else do we got? Seconds, okay. Replace with seconds with quotes. Yeah, again, we're starting with the very unsexy part of a job, which is just maintenance. Especially when you have to do things like string replacement like that. But at least it gets us warmed up for the rest of the project, for more complex things. It helps us settling with how things are laid out in the repo. So it's not too much of a bad thing to start with this kind of not that interesting and not that exciting task. And anyway, it has to be done at some point. Alright, I think I'm good here, so I don't need. I can close that one. I can close that. And now this should all be good. So one thing, I now need to. I can kill this because I changed everything, so I will need to restart all my. Yeah, also do it with Julia 1. 10. I need to restart my generation because I changed the script, which is the source for the generation of the notebooks. So I'll start there and import JuMP tutorials and weave all. So I hope the sound is okay for everyone. I'm really not sure because I don't hear myself. I muted it, otherwise I get echo. But yeah, I hope the sound is not too loud enough that you can hear my voice. Not only my keyboard, which is sometimes the case, especially when I have too many bugs around. But skipping test 4. Okay. Could be slightly louder. The microphone specifically, I assume. I try to sound. So output volume. Yes, this one. Yeah, get it a tad louder like this. I guess I'll try not to pierce anyone's ears. This should be a bit louder now. Yep, okay, perfect, thanks. Alright, so the notebooks are converting, that's great. In the meantime, yeah, I'll try to resist starting all the rest of it. I'll just stick to JuMP 021 for now, and we'll get to the exciting part, so namely the indicator constraints afterwards. Also, I think Julia 10 might be slightly slower for some things. That's not great, but at least we're guaranteed that it works with Julia 10, which is what we want. For something though we don't care, like when we run the tests themselves, we don't care about being in Julia 10. The tests are just a test. That's supposed to work. So this, can I run the test while they are being generated? I think I can, but I'm not sure. And yeah, I'm not even sure what would be a race condition on that, because this is generating the test files, and at the same time we would be trying to run the test files themselves. So if something is not generated, is everything loaded once or loaded one after the other? I'm not sure. Alright. So in the meantime, I think this will be all good for the script. So I think this will all be updated for JuMP 21, which is great because we haven't modified that many things. Oh yeah. So we haven't modified that many things, but still. I have to see what the diff in the manifest is, because I hope this is all working with Julia 10. Semi-definite models. Oh, this is where that we depend on things that depend on mathproc base. This is not great. But I have no idea why and how CSDP could just not be there. It's very mysterious. Because we depend on it in one of the files, so at some point we had to run this file and get the error. So why and how we get the error just now, I don't know. Well, this is slow now. Where is it? Experimental design. I think this is one of the last ones, I hope. Yes. No. Introduction. This is yeah, introduction again. Modeling, and we still have the optimization concepts afterwards, I think. So no, we're not towards the end yet. What I can do is at the same time resolve and see if the packages can be resolved now. Yes, they can. That's great. So this means whatever we do now, this is compatible with Julia 1.0. That's fantastic. And I will still run the test in the meantime to see, because I don't want to be generating all these files if there's an error from the beginning. So if I get an error in some file that has already been generated, then I know that there's an error in my file. If I get an error in something that has not yet been generated, I can more or less ignore it, I think. I hope that makes sense for everyone. Since we're waiting on tests, if anyone has questions on what the heck am I doing, what is this weird workflow, are those tests from your package or on Julia in general? So these tests are in the package we're working on. So if we yes, they do seem a little basic, you're right. So a basic Julia project or Julia package has source, script, or not script, sorry, source, test, project toml, and manifest. Project is how we specify our project. So it's basically giving it a name, a unique identifier, list of dependencies, and so on. And the test is a special folder that's run when you call the test task from PKG, from the PKG tool. And the file that's run first is this run test file. And this is just calling test and then going into intro and so on. And this is running all the tests one by one. So the question is, or the remark is, these tests seem a little basic. So the things that are printed here do seem a little basic because it's basically the first notebook that's printed, more or less. So what the tests of this package are doing is they are taking each of the scripts, so each of the thing in the script here, so script introduction or modeling that. They're removing all the comments because these comments are for the tutorials, not that interesting for the test. And then they are producing the same file and running it. And when you run this file, the basic criterion is it has not to error. If it doesn't error, it's fine. What we could do is add some tests on the values themselves. It's not done here, it's done for some of them, and there are some additional tests. If we go to tests, modeling, so I think there are more things here than notebooks. No. Introduction. Okay, if we go to test, and we look for the test macro, which is what you use to do some proper testing, you see that there are some tests that are run. We don't see them all because the test macro will just be printing things if we have some problem. So if we have a problem, the test macro will show something in red, like it's not doing here. Nope. Otherwise it doesn't. What's printed here is some printing function or logging function from the tutorial. So we don't always have them. So what we see in the test is what we see in the test here is just things that are printed, but the tests themselves, the only thing you see if it's not failing is something in green. Like we run 2 tests, both of them are passing. We run 4 tests, all of them are passing, and so on. If some test is not passing, then you get in detail which one has not been passing and where it is located. Like here, expression test failed, and the test is asserting that something is of a value. So we evaluated this equal that. I'll get that on 2 different lines, if you don't mind. I guess this is a length problem, or is there 1 1 that's 0 or 1 0 that's 1? Yes, we do get an error here. Huh. Okay, so the sum of both solutions is the same, but which is picked is different. In test run test, so whenever a test fails, you see in detail where it is exactly. Modeling examples, test failed, and it's in, so we get the whole stack trace normally, run text 62, test value. Okay, so it's in the additional tests. Modeling problems of on graph. Oh, that's nasty. So it's, I don't like the way this is including something and then testing the value afterwards, because we rely on the value being modified in the include itself. It's really not great. So problem of on graph is failing, and I don't know why. And that's not the only one. We also have that test failing, which is 63. Oh, and one more thing, since test is a macro, so it can return you the expression that's being tested. So you give it an expression like c equals this, it first evaluates it, and then if the expression is not true, it still has the expression itself, like the Julia code that's being passed, and it can give it to you in a string. So that's fairly nice for printing, because it can give you the expression and tell you this expression has failed, and this expression evaluated to that. So it's really practical in some cases, or in lots of cases. Alright, evaluated this. So many tests failing, it's fairly surprising. I don't know how and why. 85, okay. Some tests did not pass, yes, indeed. We are in... I completely forgot, are we in Julia 1.0? Oh! I hope these were maybe tests that were not produced yet. I think so. It's not been updated, really. We'll check if we had some modification status. So, not, oh, did I jumped out of my, that's not what I wanted to do. Alright, I wanted to go to scripts and ag graph, see modeling, yes, problems on graph. Alright, be looking directly in problems on graph and see if we modified this one. It's telling me we did not, but I prefer to be sure. So I don't know exactly why and how this came to change. I'm not sure we should test exactly the values if the object. I'm not sure we should test values in general, because it can be fairly hard to determine if an optimization problem has just one unique solution, or if it has multiple optimal solutions, finite optimal solutions that yield to the same finite optimum value. Because in that case, you can't give a you can't test a solution. You can only test the objective value. So I would be tempted to just remove them and say, guarantee that when we test things, the solution has to be at least as good as this. But yeah. Alright. Oh, the notebooks are taking forever. Oh no, okay, we're not stalled. It's not the same anymore. But yeah, I think generating notebooks is fairly heavy, even, well, especially for my poor laptop. So maybe this should be done on on an optional task, like be able to produce the tests without producing the notebooks. That would be great. In the meantime, I think I'll have to explore the tests failing, starting with the first one, which was at line 62 of the run tests. Alright, here. So this is in modeling problems on graph. Micro modeling, nope, tests, modeling problem on graphs. Okay, so it's a vertex cover problem, and the objective is minimizing the sum of the y's. Okay. Oh no, we're only testing on the last one. Let's get back to the... Can I? Yes. Okay. It's only testing on Z. Where is Z? Here. I think Z might be the last problem, maybe. Also, this is maybe not the best way of producing a graph. So maybe we'll try to modify this in the future. Or is the variable Z defined? Matching, okay. Z here. It's for a coloring problem, okay. So we're defining variables, variable Z, okay, and C, both binaries. The objective is minimizing the sum of Z, okay. Optimize this and show value, okay. Yeah, that's a classic. So the one that's failing is 62 here. So here we have a value of Z, so a value of a coloring with in total 3 items that are picked, and in the tests we also have here 1, 2, 3 values picked, so it means the objective is the same, and it's exactly the problem we described before. These two solutions are perfectly valid because we're trying to minimize the sum of Z. So these two have the same objective, these two solutions, and maybe they can be valid. I guess they are valid. Then it means it doesn't make sense to just test for this one. What we can test for is sum of, so the value of sum of Z is 3, or is approx 3. Let me pick one thing. The only reproach I have for Micro now of this editor is not having Unicode support. So I'll just get back to my Judy REPL, get this. Well, it does have Unicode support, but it does not have Unicode generation, unlike Vim, for example. So I need to get back to that. Even checking equality with floats is fairly dangerous. I'm really not really sure with this. So I guess this will blow up at some time. But we're not going to fix this now. We're just really going to fix the minimum of things to avoid things breaking. So we fixed the Z part, which was this one here. So this was a coloring problem we fixed. Again, if you have questions on any of this, don't hesitate, feel free. The second one is C, and we'll see what that is. So the test for C was failing. We're not going to check the whole input, although this is provided. So what was the... Oh, C was in the coloring also. So Z is Z, so there's one Z per vertex. There is one C for, oh, wait, I'm not familiar with this formulation. There's one Z per, oh no, there's one Z per color to know if a color is used, and then there's one C for each vertex and color. So which is one only if the vertex here, so the vertex I, we can also for style, we could also index things. So it's one only the vertex I is of color J. Okay. And we should not test for this. I'm not even sure if we should test that and how. I think we should assert that the sum over this is the number of vertex of the graph. What was the graph called? G, just G. So sum of this, so the value of the sum of C is supposed to be, so we're supposed to assign a color for each of we're supposed to assign a color, I'll be fine, with for each of the vertex. So that means we have the sum of this must be the number of vertices of G, and we'll remove this other thing here. Alright, so that will do it. The best way to fix tests is just to remove tests. Am I right? Please don't tell anyone I said that. And the last one would be F. So I assume without checking that F will be a flow problem. Line 85. Nope. 85. Oh no, modeling finance. So we're not in the graph part anymore, sadly. Yeah, I think here this should also be, we should not use equality for floats at all. So the one failing is the value of F. I guess we just have the exact same problem. So it's in finance, yes. So what is F? So this is the first problem, and the second one is an auction. Yeah, here again we should use dot products, but we're not modifying anything here. Keep in mind this is the test, so again this is a generated file. We should not modify it, even when we're very tempted to do so. This should be formatted correctly. Trying to resist here. Wait, where is this F coming from? Oh no, stupid. We're including, so the finance part is after this, but this here marks the end of the graph part. Sorry. So here it's I guess it's this flow problem, so we can get back to, we can quit this and get back to network flows, I think. Yes, network flows. So here we're defining a graph with values on the edges, only on the edges, so the diagonal has nothing. We don't have self loop. And from this size G1, okay. And from this thing, okay, now we're defining, so first the shortest path, then an assignment, and then a flow problem. Okay, and on the flow problem, we are okay. Oh, we're not even defining the graph here. We're just using the matrix directly, which kind of makes sense. So we're defining a max flow problem, and again, I think we should not test it. We should only test the objective value with an approx, obviously, and same thing here. And if things are if the objective value is fine, then we don't need this test here. We really should not use it again. So I'm just gonna remove it. Well, how bad could it be? Yes, so we regenerated all the all the tests. So it means we now fix the test, quote unquote fixed / removed. So we can now rerun all the tests with the newly generated ones for the script files we modified. In the meantime, keep in mind that I wanted to modify some things in the test files. I resisted because we are going to modify them here. That was modeling and problems on graphs. This should be a sparse matrix, but I think for this kind of size it's fine. I'm just gonna format it because this is making me cringe a bit. Can I add this like that? Yes. I find it a bit more uniform. Gplot, okay, I hope this is working. In the meantime, so my tests are running here. The now updated tests, which are even weaker than before. This is fine. Again, formatting. Sum of this times that. Okay, so we're just going to use a dot product of this and this. So this broadcast here is doing element-wise multiplication. This means this will create a new array of so the element-wise product of this that's a row and this vector. What we're doing is just a dot product, so we can just remove that. Great. One thing we'll need is linear algebra here. So it was a great initiative to add the test on this, but again, with optimization we should watch out what we test on, because we don't want to be testing on things like values, optimal values of your variables, if you cannot guarantee that you have one unique optimal value, which is often the case. How are my tests doing? Oh no, my test errored. Test. Oh, invalid macro. I did something I should not have done. That was 63. Let's quit that. Oops, nope. Here. Tests. Oh no, yep. Oh no, that's also a proxy call. Let's rerun the tests. So I hope. Oh no, I just one test failing. Oh no, the test didn't even fail. There was just an error in the test script, and so in that case it will just stop everything. In the meantime, I'll go back to this and keep formatting things. One thing we could use is Julia Formatter, which is now getting fairly interesting and mature. Let's try to find it. Formatter. Yes, this one. And I think there's no. Oh, we just saw a GitHub action on the side. So there should be a GitHub action to format Julia code, which would be fairly nice. But yeah, we could use this and just format Julia code with that. So we could format the tutorials and stop getting paranoid about formatting all over. Because I'm losing a bit of time, but again, this is not a big deal because I'm doing it while my tests are running to avoid blank moments. And fine. No, network flows. I wanted to fix some things here too, I think. Alright, that's fine. Here. Oops. Dot of this and that. Which means formatting here. Up. We don't need the semicolon apparently. Okay. Oh, there's a nasty space all over. I should have used this opportunity to just no. Alright. Formatting is done. Okay, this is fine. So all this formatting is not that capital, so it should not impact our generated files or tests. I hope. No. No method matching value. Oh no, I forgot to. No, not broadcast it. C is supposed to be a variable here, isn't it? Yes, here, but that's in the space there. How is C float 64? It's supposed to be a JuMP variable, I thought. Problems on graphs, and where is C defined? Oh, C is the value of it already. Okay. So no need for value here. Okay. So I can rerun my tests. Oh, tests are not finished? Okay, there was just one error. I need to rerun them anyway, so I'll just cut it short. Up. Again, testing on Julia 1.0. I think I can just test on Julia 1.4 because this is too slow otherwise. Whoa. Did I paste something? I think my tests are still running. Yes. I had to cut it short. And test. So in the meantime, since I remodified some stuff, I think I'm gonna have to regenerate again. But if things pass, I guess we could just go on and have a first pull request done. What time is it? Yeah, it's already more time than I was intending to spend on this one. It's always more time. Classic. So the other thing I wanted to do is create a new notebook or a new script for indicator constraints. So I guess where could it go? Optimization concepts, maybe? Yes, I mean, it could be similar to integer programming. Indicator constraints .jl. Constraints. Alright, we did the hardest part, I guess. Well, we already know how to set a variable as integer. So no, we'll not use this, but yes. Oh, that's perfect. So the integer notebook started with modeling logical conditions, and this is exactly what indicator constraints are for. So maybe I'll still need to remove this. I don't know. But anyways, I guess we can just keep the same notebook. Doesn't hurt. And add just some constraints to it. Question: did you do a bridge between indicator constraints and complementarity constraints? This one, no, I think, and the reason was, so there was an issue about it and some discussion on math opt interface. The reason we didn't do it was, after some discussion, is that it's a bit of a more subjective transformation compared to other bridges. So bridges, for those who don't know, are model transformations. So going from one expression or one constraint to another. And indicator constraints to complementarity is just a bit ambiguous on how to best formulate it. And what's the best formulation depends on which solver you're using. And you don't want, you often don't want formulation for bridges that is really dependent on performance-wise on which solver you have. Otherwise, in that case, it's better to, or at least it was considered by the JuMP maintenance team, that it was better to let the user do it if they want to, and not to do it for themselves, because bridges are fairly automatic, and if you don't worry about it, it works, but it means you don't see what's happening inside. In some cases that are performance critical, you might not want something that's subjectively better in some way or some other, or at least there's been no way to do it for a moment. I'll check afterwards what was the issue or pull request that was open about it. But yeah, good question. It's a fairly open topic, and indicator constraints are still fairly recent in the JuMP world. What kind of bridges already exist? So a bridge is basically a transformation of a model, and the bridges that exist are usually fairly basic. Like you have a model that is like that, and you only support inequality in this sense. Then you will just flip the sign of this and that, and just get and transform your constraint like this. This is the kind of bridge that exists. A bridge, I think the line is a bridge has to be kind of trivial in some sense. If a bridge really requires heavy formulation, or more importantly, if a bridge has different paths, like you could reformulate it as this or as that, and the two formulations are, you can't say one is better than the others, and the two formulations are using the same set of constraints in the final node, then it's not that good, because it means you're taking choices for the users about modeling and not about just convenience. While the one like inequality to equality and so on, this is really convenience. And indicator constraints are bridged also, and the biggest bridge that exists for them is mostly transforming an indicator constraint into an SOS1, with SOS1 being for, let's say, two variables x and y. So this is a constraint specifying that at least one of the two has to be 0. And you can reformulate indicator constraints using this. Okay. So in the meantime, I'll check my tests, which have passed. Oh, wonderful. This big thing here is a graph described in a text way, like a graph in the sense of a plot of a graph. So in the meantime, what I'll do here is import JuMP tutorials if it's not done already. No, it's not done here. And I'll just reweave everything, because I think we are pretty good here. So I'll just rerun the weave process, retest, and then I think we're good to go. In the meantime, yes, I just created a new file here that we're not going to commit. In the meantime, since I'm fairly confident about what we did, I'll just commit everything once and prepare this for a new PR. So this will be JuMP version 2021. Ah yes, line ending are always a nightmare. I think I got the problem on the other stream also, I'm not sure. But yeah, anyway. Yes, so the only thing we have now is this that we don't want to add yet, because we want it for the next pull request. And this one, which is just our to do. And as soon as we push the indicator thing, we can just cross this one out, which just always feels good. And this one we're definitely not gonna do today. Alright, so tests were passing, that was the test. This one is just rerunning everything. Oh, why is this regenerate? Oh no, I think... No, okay, I'm on Julia 1.0, fine. Git diff. Why is the notebook? Oh, really? I really don't get how notebook code generation works, because anytime you do anything with a notebook, it will just be regenerated. Something is going to be modified. You don't know what, but something is going to change. Anyway, in the meantime, we can create a new branch, which will be indicator tutorial. And oh, I should not have checked out yet. We're still gonna work on this for a moment, because we're still doing modifications and so on. This one's a bit too big. Alright. In the meantime, I can still work on my scripts. There was optimization concepts, indicator constraint here. Well, we already know how to set a variable as integer or binary for variable macro. So this will be while many integer, I don't like calling them programs because programming today has become a fairly unambiguous word about computer programming, like writing code to produce computer programs that are executed. So I don't like the term programming for that, for mathematical optimization. I think this is also one reason that motivated changing from math prog base to math opt interface, like getting some proper vocabulary for this. So while many integer, so I don't know who's gonna see this video, but I guess some professors are gonna see it. Maybe I'm gonna get in academic trouble for saying this. Strong opinions in that field. But anyway, while many integer optimization problems can be modeled with linear constraints. Oops, no. While many integer optimization problems can be with linear constraints, some logic based constraints and disjunctions are better expressed as disjunctions. Yeah, great. Some logic based constraints are better expressed as disjunctions or logical implications. I think this is a correct denomination for indicator constraints. Many solvers have integrated many MIP and MIP solvers have integrated I'm not sure we can use MIP, like using too much jargon creates some barrier for entry for newbies, for people who want to learn both optimization and JuMP. So maybe we'll change it afterwards. I don't know what you think, if this is too specific or unambiguous enough. So many MIP solvers have integrated indicator constraints, a form of indicator constraints, which allow the modeler such expression to express such logical implication, a form of indicator, such constraints. Using JuMP, using CBC. So regarding the questions about bridges, so CBC is one perfect example of why we have bridges for this. So it doesn't support indicator constraints out of the box. Not that I know of. Maybe the last versions of CBC, but not the wrappers we have in the math opt interface world and in the JuMP world, at least. So it means I couldn't use this feature normally. I would have to use one of the solvers that do support it, so including Skip, that was the first one to support it. Also Groby, Cplex, all of which are not open source. None of which is open source. And that would be quite a shame for this tutorial, which is supposed to be accessible directly. But using CBC with the bridges, since CBC supports SOS1 constraints, I can express my indicator constraint and it will be remapped directly to the constraints I want. So to a SOS1 constraint which is supported by the solver. So that's quite a great thing. So we'll remove this, even though I could be tempted to just keep it, because this is exactly what we want. Except it's done here using a big M type constraint. I will code this revisiting disjunctive constraints. I don't know why OR. OR, okay. So I thought this was operations research or something, but no, it's OR, like the logic OR operator. So revisiting disjunctive constraints. So in the, oops, no, I will need that and that, no, that. So in the integer optimization notebook, disjunctive constraints was, yeah, was tackled with binary variables and linear bound constraints. Although this produces a straightforward mathematical problem, it can have some, it can result in how deep do we want to go in the details here? Maybe not. This is the beginning of a notebook. We don't want to scare people off. It can result in performance issues, and we'll just stop there. So we'll just keep this one, I guess, this description. And here again I will just use a dot. Oh cool, the tests are passing, nice. So instead of prime here, I will use a dot product, and same thing here, which is in linear algebra. Oh no, this is a LaTeX part, so I can just use C dot. In which all components of A and C are non-negative, okay. I would like to model a requirement that at least one of the two constraints is satisfied. So let's focus. Either AX is greater than B, or say X is greater than D. Okay. So X, so Y in Y in 0, 1, and we'll do Y X1, and then this will be right arrow. I never remember if right arrow is going into the right or coming from the right. Going into the right, okay. Right arrow, maybe this should be a fat arrow like that. Like think this is, yes, like that. So y equal 1 implies this, and y equals 0 implies, and here we can use our c dot also. And here we don't need the y anymore, so that's the great part. So here we'll do a break, and we would like to model a requirement that at least one of the two constraints is satisfied. One possibility, I'll need to reopen the other notebook. Integer, because I need this problem here. One possibility is to have is to use linear constraints with a bound. You know, that's a bit vague, but with a bound activated by the binary variable y or its complement, and that would be 1 minus y. This is a bit too big, the lines here. Okay. Oh, it's complement here. So that's the first formulation. This approach is commonly referred 1R, 2R, English. Referred to. Alright, let me shamelessly Google referred and verify if it's 1R or 2R. I guess it's 2R, obviously, because I just used one. Referred, 2R, of course. Alright, sorry for this English. So this approach is commonly referred to as big M quotes, big M constraints. And then we'll add this. Alternatively, same thing. No, there's a E here. Sure. Okay. Alternatively, we can encode our disjunction using indicator constraints. An indicator constraint specifies that a constraint is activated, a given constraint is activated only if only if the value of a binary only if a binary, a boolean, the value of binary is 0. 1 or 0. Is 1 is only if it's 1 or 0, but how to say it in not too stupid way. Only the value of a binary is, let's keep it simple, 1. Of a binary variable is a pre-specified value. An indicator constraint specifies that a given constraint is activated only if the value of a binary variable is is equal to a pre-specified value. This doesn't need a line. Right-a-row. This is a... Oh no, I'm not in. Note that this is an implication, but not an equivalence. Yeah, IE is correct here. Yes. One can have AX greater than B without one. But if y equal 1, then this one must hold. Okay, I guess that's decent for a first draft. I'm not sure how confusing or boring this one is. It's very hard to work on prose versus code, because yeah, I guess I'm more used to check things in English than I am with a program. Programs just run red when you're not correct. English does not. So we now have this, and the previous problem is reformatted at that. I'll just finish this later, the adaptation of the prose. For now, we'll just get to the code. So ACBD is not changing. Is this yielding a matrix? Nope. Yes, it is. Okay, yes, I see. Maybe we should have a number of rows and columns be different, just to distinguish them. So that's the number of rows, number of columns. Oh, we'll have more rows than columns. Oh no, yeah, no, okay. The model is called model, not M. Okay, so this is same thing. B is N. No, B is M, and D is M also. Oh, we should maybe distinguish between the number of no, it must be the same number of rows for the B part and for the D part. Okay, so now we'll transform these into indicator constraints. So for indicator constraints you need the same let's see, you need binary variables. That's the important part, because the first component of the constraint has to be a binary. And then there's a special syntax which was introduced in JuMP 21, which we'll see just now. Let me just grab. Alright, that's the JuMP website, and I'm just looking for indicator. There should be something. Bridge constraints. Nope. Constraints. Alright. Constraint names, quadratic, indicator constraints. Perfect. Okay, that's the syntax. So as we mentioned, so this has to be a binary. That's important. And then the syntax is the binary implies this linear constraint, or this constraint which doesn't have to be linear. And on the other side, if you want not, then you add this exclamation mark, this blank, or a logical, but I don't like overusing Unicode when you can use something else. Alright, so I just copy one example to keep with me and get back to this. So constraint, here we have so this would be the first one, and the first one will be y implies a times x. Oh, one problem here. I'm not sure indicator constraints will handle vector values. I don't think they will. So we will have to specify this as multiple constraints. We'll still try it anyways. So it has to go in curly brackets. One thing that would really be cool is being able to broadcast that, but I don't think that works for now. We'll still try, but well, I'm skeptical. So y implies this, and not y implies the other component, which is this one. So we don't need the y part anymore here. So here, one big argument for indicator constraints versus big M type is that they read so much better. If you look at this, it reads like English. My constraint for this model is that if y, then this must hold. If not y, then this must hold. And that's it. And we will not print the rest here. Okay. It's conditional constraints. Well, I don't think we need all of that for sure. No, we won't. And there's also special order set already done, so we won't need to mention them. Maybe one thing would be moving some parts of the integer tutorial into a special integer constraint tutorial, including indicator and other things. Ax minus b in MOI non-negative could help. You will have a scalar vector function instead of a list of scalar affine function. Yes, that could also be a possibility. I'll just copy paste this one. So that would be the idea. Thanks, Alexi. That will be the ID here. So this here will be a vector expression, and they all have to be non-negative. So that could be a constraint. So for the model, and this will be an alternative to this one. Anyway, another one will be maybe this broadcasts well, and in that case we could just try to broadcast this operator there, and broadcast just everything. If this works, that would be wonderful. So we'll just try the three of them. So this would be non-negative like this. And this will be also y implies curly brackets. Okay, so we'll just try all of them and see what breaks and what doesn't. Alright, so we don't use any specific solver or anything here, so this would be very straightforward. So we have JuMP loaded, I think. No. Oh, in the meantime, yeah, I completely forgot this. So this here run, so the generation run, I'm just going to test everything, and if this works, we're pushing. So in the meantime, I'm just going to paste the beginning of it. So this was just my first part of the notebook, and then I'm going to try one by one all my formulations, see which one break and which one doesn't. Alright, this one, first one. Okay. Inconsistent use of broadcast of a dot in symbols to indicate vectorization. Okay, so this one is eliminated. Second one was this one, because this is a proper use of vectorization, I think. If this works, that's neat. Oh yeah, it does work. Wonderful. So it means we use here y for each of the constraint, and this prints super well. So this prints y implies the first one, y implies the second one, and so on. That's great. I also use the formulation by Alexi, which is worth mentioning because this is bringing another flavor of syntax, which is the math opt interface one, and that's me non-negatives, I think. Nope. MOI that's non-negatives. Alright, I think it needs the dimension, which will be here, the length of B. No method matching build indicator constraints. I don't know what that is. Oh, that's the error function. Variable ref, vector constraints, non-negative. Okay, yeah, interesting. So here it's telling me that I have no way to build a constraint of this form, meaning it's not even my solver that doesn't support it. It's that I think this is supposed to be, so the one we put here is supposed to be a scalar function, while oh yeah, non-negative is a vector function. So it will be yes, vector function, and what we need is scalar functions. So when we do the broadcast here, so this super good one, this one we can forget. When we do the broadcast here, this is propagating everything into a vector of scalar functions, broadcasting everything, while here we have it's expecting one constraint and it gets vector constraints, which it cannot handle apparently. It's still an interesting point. Will it make sense to have vector constraints here? Maybe, yes. Which should go back to broadcasting, but it needs, I think the problem here, it needs to know how to broadcast this, because in the end you're saying y implies this constraint, and if I can decompose this constraint, it's fine. If I can't, then I'm stuck with it. So I guess that could be a reason why this wouldn't work with, or more specifically, why the constraint in curly bracket here has to be a scalar function and not a vector function. So this means here the syntax that will work is this one for the second constraint. Where was I? Yes, here. Oh no, yeah. I'm just gonna redo it just for the sake of seeing my constraint being printed. And it's printing super well also. So not y implies this or that or that and so on. Cool. I'm not really sure what else should be done here. So this one I'll just I leave it, but comment it for now, because I think this is worth getting back to with the maintainers of JuMP, saying, hey, this could be valid in some way, and could we make this valid, and so on. Then, so the two constraints that are interesting to me are these ones. What I'm gonna do is name them, and this is gonna be hard. First thing first, I'm gonna go the easy way and just building the model. And naming them, so that would be the left constraints. Oh, that's ugly. Left cons and right cons. Yeah. And I've had worse name for variables, but still not great. And then so adding some a bit of text. So what could we say on this? For left constraint is activated for one big thing is all the left constraints. So it means all the A's are activated by this, not just one, because this is this expression here implies m constraints and not just one. The m left constraints are activated whenever if y is 1, while I'm missing a bracket here, while the right constraints are activated if y is 0. One thing we could do is maybe I'll add a to do here to figure out why this doesn't work. Okay, no, I did this here. I guess I'd add show show this and right. Okay. Yeah, this should work, I think. Should we add some tests to that? I don't know. And we don't even need any of these in the end. And maybe we should add a proper example. We could add an example from MOI, but I think I'm running a bit out of time. Oh yeah, I'm a bit late. So I think this is fine, and I'll just, so my test passed, so this time I'll just consider everything is fine. Oh no, oops. Okay, I generated these by accident, but the rest of it can be committed. So generation from Julia 1.0. Oops. Push, and I think I have access to origin now, so I can push directly to origin JuMP 021. I'm not sure about that. Clear opt, JuMP tutorials. Do I have remote add? I remove origin. Remote add origin. Yes. And push origin JuMP 21. Yes, fine, perfect. Okay, so we are now good for the first line of the to-do list, which obviously was supposed to be the easiest. And now, so we can check out, get back to this one, and I think I will have to regenerate that for now. Import JuMP tutorials, and JuMP tutorials with file, and that's optimization concepts. And indicator constraint. All good. And I think the best way might be to visualize the result in Jupyter Notebook to be sure that everything is fine. So what I'll do is launch Jupyter Lab from here, because this is, I guess, the best way to visualize LaTeX and so on. Alright, so this is here. I hope this is not too small. Indicator constraints. So I think I will be able to remove this because I haven't used them now. Oh, well, that's not nice. So my LaTeX didn't render properly. I wonder why. I guess there might be a mistake somewhere. I mean, LaTeX-wise mistake. Oh no, okay. Map processing error. Oh no, okay. It was just a bit slow. One thing we might want to do is align things on the right and not on the left. So it means we need an end on the right hand side of all our equations. Am I looking at the good thing? Oh, it was before it was generated, I think. Yeah, 26 minutes ago. That's not good. We want something that was generated right now. We can close this one. Do I have to force it? Whoa. No method matching notebook string. How come this appears just now? So we fixed an error like this on the last stream, but I wonder why this suddenly reappears here. Notebook, and then all the rest is keyword arguments, and this is in JuMP tutorials 86. Source 86 here. So so the string is the source path, out path is this one. How come we didn't catch it before? Timeout, yeah, this might be timeout. And NB convert option, yeah, it looks like it. And no Jupyter path. Okay. Good. We should be fine with this. It means we have to reload. We have to reload the package itself. It's quite a bit of logistics in the end, but yeah, I hope this will be worth it. In the end, I'm not sure what we should add to this indicator constraints tutorial. I'm not sure what's necessary, because it's really simple to use, and we're placing ourselves from the user perspective. What's inside is fairly deep, and you have to go to discrete optimization experts to even get how to derive cuts and so on. But how to use them, it's way simpler than the actual reformulation that people are trained to do. Okay, so we'll go back to the Jupyter notebook here. No, that was not that. This one. Seconds ago. Perfect. Okay, it all seems to work fine. This is a bit ugly, but I think this is because of a dark theme I use for Jupyter. And that's fairly ugly. Why? Yeah, I thought this will... Oh no, yep, I need to re-execute. So I need to re-execute the notebook to get this working. Okay, this seems to work. I'm just gonna load everything. Yeah, also, before publishing anything like this, I'm gonna have to transfer this to an issue, like a proper issue in JuMP. Or, yeah, I think it will be a JuMP issue, not a math opt interface. And then remove this from the notebook, because this is definitely not going to be users. Do you have an application, nice example, to see where that kind of constraint are required? Well, it's tricky because it's fairly advanced to get some really good ones. I mean, it's already some real applications. I don't have a very typical one where this will be better. In general, I would say if you have a good bound, like a very tight bound on a variable, then your big M-type formulation will be fine. But if you don't, then this thing will help you a lot, because you're just specifying your disjunction to the solver, and the solver knows how to derive some cuts from it. So one thing we might want to do is just println oops, a broadcasted println on all of that and all of that. Yes, that's better. With a semicolon here. But yeah, typically, to speak of things I know a bit more, in bi-level optimization you often need this, well, you don't need them, but this kind of constraint is super useful because determining a good big M itself is hard, as in NP hard. And so you don't want to solve an NP hard problem just to get a bound to solve your other NP hard problem. So that's why this kind of constraint is super useful for applications I do care about. Yeah, but in general, if you don't have a good way to get a bound on some of your variable, you might as well use, for example, if you have two variables or two groups of variables, one is implied by one condition and the other is implied by another condition, like constraints, I mean, then if one of them has good bound, you can use some big M constraint, and on the other, on which you don't have good bounds, there you can use an indicator constraint. You don't need to have the two pairs like this to make it work. Alright. So it will be constraint if y is 1, and then constraint if y is 0. I will just take that back and put it back on my script. Micro scripts. Here. What we could do is use one of tests from the method interface tests that are actually used to test indicator constraints. Yeah, we could actually do that. Let's see. So it will not be in JuMP syntax, so we'll need to translate it. But at least we'll have something. Yeah. I'm not sure how late I am on method interface. As in, how many commits do I have? Oh, no, I'm up to date. Cool. So it will be in src test int linear and then indicator. Yes. Ah, cool. Yes. So linear problem with indicator constraint. So I'll just put this on the side. This here. So here we have a binary variable z with z1. So we only have activated on true here. z1 implies x2 is smaller than 8, and z2 implies this inequality, and then z1 and z2 have to be greater than 1, so it means at least one of them is active. So it means here we also have a disjunction. We could also, instead of using z2, we could use non-z1, but we decided, at least in this test, to have two variables. I think this is also useful when you have a solver which supports the binary activating the constraint on 1 but not on 0. Then having this kind of formulation helps. Alright, so I just copy this here over example. How is the title syntax again? Yes, like that. Example without activation on 0. It is possible to express a disjunction with only indicator constraints activated when the binary is 1. Consider following problem. And then I'll just reuse my align. Ah yes, here I said I wanted to align everything on the right. I think this will work if I add it on this side. I hope. Also, I said I wanted some C dots instead of the prime. Building the model, yeah, this one has to be removed. Example without activation on 0. Oh, yeah. What I wanted to do is, of course, just copy the syntax here, and then begin align. So what I usually do is max. So it's max on the y x of no, there's no y here. Or xz of 2x1 plus 3x2. Okay. Y, so it will be z1 implies x2 smaller than 8. No, we first also have a constraint that is not an indicator but a simple linear one. x1 plus x2 smaller than 10. z1 equal 1 implies x2 smaller than 8, and z2 equal 1 implies x2 plus frac x1 divided by 8, no, by 5, sorry, is smaller than 9. And finally, yes, z in 0, 1 exponent 2 and z1 plus z2 has to be greater than 1. Nope. Kick. Alright, I didn't forget anything, I think. I guess we can just number our equations now. I'm not sure if sub-equations will be supported. We can see that after. So, in the end, so we don't need that anymore. Alright. I think this would be even easier to start it from the model compared to starting from MOI, which is way more verbose. You see, writing a linear function in MOI is one of the worst things ever. A vector linear function, just forget it. I mean, it goes banana. You have to write a vector affine function of vector affine terms which contain scalar affine term. I always lose myself in these. I mean, we should find a solution for that. So, let's write model. Yeah, let's rewrite it as model. Forget the bad names. Model, and we will give it the CBC optimizer. So 1, 2 and Z1, 2, and Z is a binary. Then constraints. So the first one is sum of x is I don't have smaller than 10 constraints, and then Z1 implies the first one implies x2 is smaller than 8, and the second one is a 2 implies x2 plus x1 divided by 5, nope, is smaller than 9. And the last one is sum of z is yes, I'm wildly copy-pasting Unicode codes while this problem has not been solved. Yeah, no, and that's just 1. Okay, then the objective, and we're close to getting something fine. So the objective on model is to maximize 2x1 plus 3x2. So we could use a dot syntax, but we can just scalarize things here. x1 plus 3x2. Alright. So I'm gonna test this once to be sure I didn't do anything stupid, or not too stupid. And in the meantime, if you have questions, just ask away. And once this model works, I think we're gonna close the stream there. And yeah, I don't think there's much more to do here except some cleanup. So if it gets what I'm expecting, then we'll just stop there. So if you have questions on indicator, how it works, not how it works on the math side, because I would not be capable of answering most of it. Comma missing. Model max. Oh wait, so it does need times explicitly, I think. Oh no, that's fine. No, all the rest of it went fine except the objective. Okay, yeah. Interesting, I can't remove the times here. That could be another bug. I'll check that, and maybe instead of polluting my code, I might add all these things to add in my to-do list. So this, and what was the other one? The other thing to add was yes, that. Here. So I have things in mind to post issues or investigate what's happening. Okay, so it works. Oh no, no, optimize model. Okay. Problem is unbounded. Is it? Did I forget some of it? It doesn't look unbounded to me. I think the result expected is one very good thing to debug models, at least for me, is to print the model, and it prints a LaTeX-like version of it, which is really useful. Z1 implies this, and Z2 implies that, and no, we need Z1 plus Z2. So the question is Z1 plus Z2 is smaller or equal to 1. And now the constraint here is you need at least to satisfy one of the two. And by setting Z1 plus Z2 is greater or equal to 1, you say at least this or that has to be active. You choose which constraint you want, but you have to activate one of them. One thing I could do is compare the result to another solver here, and if this fails, this might be in the implementation BC has. I don't think I have any solver there that will support this, sadly. Let's see, maybe in my top folder, which one do I have here? Yes, I have Cplex and Skip, so I'm just gonna do it here. So I'm not in the project anymore. I'm in the environment 1.4, and so this means I have access only to the packages that I installed globally here. And so what I'll do is I should have put this in one of my tabs instead. What I do is just copy the model and see if I get the same result of unboundedness, which is really not supposed to happen. So my suspicion is there might be a bug in the bridge, which is really not great. Yeah, I really hope that's the last thing, the last possible lead would be a bug in the bridge from SOS1 to indicator. Alright, so I'll just do model equals I just replace this with Cplex. That's how easy changing solvers is. And I'll just paste my model with exactly the same syntax. And Cplex does support natively indicator. I think if it's been merged and released, I hope. We'll see. If it hasn't, then I can switch to skip, which surely supports indicator constraint because it has supported them for a really long time now. At least, I'd say almost 1 year. Unbounded. Okay, that's bizarre. Okay, so it might be a bad news. It might be really bad news for the bridge. Yeah, I hope that's not it. I hope I forgot something, but well. So again, exactly the same syntax except changing one line. And this. Problem solved, optimal solution found. Okay. So how come? So it means my bridge might be broken somewhere. I'm not sure. Huh. Yeah, that's in any case that's bad news. Anyways, so the solution. So the solution for Z is picking the second constraint, and for X is this and that. And I think in that case the optimal solution is unique. So what I could do is I'll just add some tests here. And I'll test on approx. Oops. Test that JuMP value Z is that all JuMP value Z correspond to 0, 1 approximately. And for X it would be these ones. So the thing is, it will now not work because of this weird bridge issue that I hope it's something I wrote wrong in the problem, but I think I always remember these results, so that's very bad news. And I just show. No, I don't think showing the values here will bring anything. What could be done though would be, I'm not sure if plots is used in the rest of the notebooks. So I can close this one. Because what we could do is, since it's a 2D problem, if you don't consider the indicator, just on in the X space, it's a 2D problem. So we could just plot the resulting constraints, the linear constraint in the x1, x2 space. That would be great. But I don't think I see plots here. That would be a nice addition, maybe. Alright. In any case, that's it for now. So these tests will naturally fail. So I think this will require a bit more investigation, which I will do, I guess, offline, because this will be a bit more tedious. So yeah, if you have questions, don't hesitate to reach out on in the Julia community in general. People are fairly nice on the JuMP or Slack or Discord or anything. Alright.